Welcome back to board preparation series for class 10 on my channel Mathify with Minakshi. Today in this video we'll discuss important questions from chapter number 10 circles. But before moving to questions you should know what is secant and tangent. Just see this figure carefully. A secant is a line that intersects circle at exactly 2 points passing through the interior, and every secant contains the chord of a circle. Whereas a tangent is a line that intersects a circle exactly at one point without passing through the center. And this point is also known as point of tangency or point of contact. Now let's move to two important theorems of this chapter. Theorem 10.1. The tangent at any point is perpendicular to the radius through the point of contact. That means we have to prove that radius is perpendicular to tangent. So for that, we'll draw one circle with center O and draw a tangent AB. Where they intersect, we'll mark that point as P, point of contact. So we have to prove that OP is perpendicular to AB. Now, how we can show that OP is perpendicular to AB? You have to just prove that OP is the shortest distance from point O to the line AB. As you know that perpendicular distance is the shortest distance. So for that, we'll take any point other than P on line AB. So we have taken point Q and then we'll join OQ. Wherever this line intersect the circle, we mark that point as R. Now we have to show that your OQ is always more than P. How will show that? Just see here that your OP and OR both are equal to radius. Yes. Now what is my OQ? My OQ is, you can say, OR plus RQ. Yes, and OR is radius plus RQ. And on the other side, I have OP, which is equal to R. Yes, now which one is more? This is R plus something. So we can say that my OQ is more than OP. So we have shown here that OP is the shortest distance from the point O to the tangent AB. And this holds for any point other than P. So that's why we can say that OP is perpendicular to AB. Now let's move to the most important theorem of this chapter, theorem 10.2. In theorem 10.2, we have to prove lengths of tangent drawn from an external point are equal. That means if you will draw any circle with any center, let's we have taken that as O, and take any external point A, if you will draw two tangents from this particular point A, that means AP and AQ, you have to show that they are equal in length. So how we'll do that? First we'll do a construction, we'll join OP, OQ and OA. Now if we'll prove that this first triangle and second triangle are congruent, we can say that my AP is equal to AQ by CPCT. So how we'll prove that? Just see carefully. In first triangle, that is in OPA, we can say that OP and in second triangle OQ are equal because both are radii of same circle. This first thing. Second, you can say by theorem 10.1 that both are 90-degree as radius is perpendicular to tangent 90-degree, and third OA is common. So by RHS, by RHS you can say that the triangles are congruent, and that means you can say that by CPCT AP is equal to AQ. From this theorem we can deduce two more things. First, that these two angles are also equal. Yes, we can say angle 1 is equal to 2, and similarly we can say that angle 3 is equal to angle 4 by CPCT because both the triangles are congruent. So all the corresponding angles should be equal. So I have written that note for you. See here carefully that your angle POA is equal to QAOA by CPCT of first, where we prove that the triangles are congruent. And if you want to use this in exam, you can write this line: tangents drawn from an external point subtend equal angles at center. And similarly, if you want to write that this POA is equal to QOA again by CPCT of first part, so you can write directly in exam: tangent drawn from an external point are equally inclined to the line joining the center and that point. So this is important for you because you can use this in exam. Now let's move to one markers. Question number 1. Number of tangents that you can draw to a circle passing through a point lying on the circle. So for that, how many tangents you can draw? If you have a circle and point lies here, so only one tangent. So here the answer is 1. But if the point lies outside the circle, then how many tangents you can draw? So just see here, we have a circle and let's take one point outside. So we have two tangents. We have two tangents. Okay, so always two tangents. When a point lie outside the circle and when a point lie on the circle, one tangent. In the given figure, AB and AC are tangents to the circle with center O such that angle BAC is 40 degree. Then calculate BOC. This is very easy, as you know that radius is always perpendicular to tangent. You can say this one is 90. Similarly, here radius is perpendicular to tangent. This one is 90. Now using ASP of a quadrilateral, you can say 40 plus 90 plus 90 plus BOC is equal to 360 degree. Yes, ASP of a quadrilateral. So just add this 90, 90, 180 plus 40, that is 220 plus BOC is equal to 360. That means your BOC is 140 degree. So here the answer is 140 degree. Even you should know one thing, because these two angles are always 90 B and C. So sum of these two angles A and this is always 180 degree. So you can use directly that 40 plus BOC is equal to 180, because this question can come in MCQ. Now let's move to question number 4. In question number 4, it's given a quadrilateral ABCD is drawn to circumscribe a circle. Circumscribe a circle means outside the circle. So we have a quadrilateral outside a circle. And it's given BC is 7, CD is 4 and AD is 3. We have to find the length of AB. For this, you should know one result, that whenever a quadrilateral circumscribe a circle, then sum of opposite sides are equal. That means AB plus DC is equal to AD plus CB, or you can say BC. As we have to find AB, so let's write that as it is. Now what is our DC? It's 4. AD 3 and BC 7. Now what is 3 plus 7? It's 10. Just transpose 4 to that side. So AB is 10 minus 4. You can say it's 6 centimeter. So C option is correct. Let's move to question number 5. In question number 5, it's given PA and PB are two tangents drawn from an external point P. So we know that their lengths are equal using theorem 10.2. And it's also given that your angle APB, this angle is 50 degree. We have to find this angle. How we can do that? As you know that PA is equal to PB, so we can say that these angles are equal 1 and 2, because angles opposite to equal sides are equal. Now use ASP, that angle 1 plus 2 plus 50 degree is equal to 180 degree. 1 and 2 are same, so we can write twice of 1 plus 50 degree is equal to 180 degree. If you will transpose 50 to that side, you will get twice of 1 is equal to 180 minus 15, that is 130. So your 1 is 130 by 2, you can say 65. Now you can use your theorem 10.1 that says this angle is 90. You can say angle 1 plus angle OAB is 90 degrees using theorem 10.1. So from there you can say 65 plus angle OAB is 90 degree. So your OAB is 90 minus 65. You can directly write 25. But in exam, if it's a MCQ, no need to do that much. You should know one trick. I'm writing here for you, that whenever this type of figure is given to you, so you should know that this angle OAB is always half of that angle APB. Just learn this trick. So here your OAB is half of 50. You can directly say it's 25. Similarly, you can say that your APB is double of OAB. So no need to do this much in exam. You can directly use this trick. Now let's move to next question. Question number 6. In question number 6, it's given that O is the center of the circle and PQ is the chord. And tangent PR at P makes an angle 50 degree with PQ. This angle is given to us, that's 50. You have to find POQ. This you have to find. Let's take this as X. This we have to find. Now you know one thing, that here these two sides are equal, OP and OQ, because it's a radius. So can we say that these angles are equal 1 and 2? Yes, because angles opposite to equal sides are equal. Now, if angle 1 and 2 are equal, now what is angle 1? You can say that 1 plus 50 is 90 using theorem 10.1, that radius is always perpendicular to tangent. That means your angle 1 is 90 minus 50, you can say 40. Now 1 is 40, that means 2 is also 40 because 2 and 1 are equal. Angles opposite to equal sides are equal. Now use ASP. X plus angle 1 plus 2 is equal to 180. Now 1 and 2 both are 40 40. That means x plus 80 is equal to 180. You can directly say that your x is 100 degree. So which option? A option. Now let's move to question number 7. In question number 7, it's given the angle between two tangents drawn from an external point P to a circle of radius 3 centimeter is 60 degree. That means here it's given that radius is 3 centimeter. You can say OA and OE is 3 centimeter. Also it's given that your angle P is 60 degree. But we have to find this OP. How we can find this OP? Let's take this as X. Now you should know one thing, that whenever we have a right angle triangle, and in a right angle triangle, if I can find this angle and this side, one side is given, you can always use trigonometry ratio. So how I can find angle APO? You know this thing, that angle APO is equal to angle EPO, and both are half of APE, because we have already seen this thing in note of theorem 10.2, that by CPCT these two angles are equal, and because they are congruent, so both are equal to half of 60. That means you can say directly it's equal to 30 degree. Now we know this angle, that it's 30 degree, and we know that it's 90 degree using theorem 10.1, that radius is perpendicular to tangent. No need to write the explanation because it's just for a 1 mark. Now I have a triangle. I will draw that triangle separately. I have a triangle. This side is 3 centimeter. Here it's 90 degree. Here it's 30 degree. Now can I find this side? Just think carefully. What is this? This is hypotenuse opposite to 90 degree. What is this? Because this is opposite to angle, that means perpendicular, and here is base. I know this side and I have to find this side. So which trigonometry ratio is related to perpendicular hypotenuse? That is sine. So you can use sine 30 degree is equal to P by H. Now what is sine 30? It's half. P here 3 and X we have to find. Just do cross multiplication and you will get your X is 6 centimeter, and that's your answer. So whenever they will ask for any side and you know one side and one angle other than 90 degree, you can always use trigonometric ratio. So let's move to question number 8. In question number 8, it's given AB, AC and PQ are tangents in the given figure, and AB is 7 centimeter. So let's mark that. It's given that AB is 7 centimeter, and we have to find the perimeter of triangle APQ. Just learn one direct formula, that this perimeter is always equal to twice of length of tangent. So here that is given AB, that is 7. So answer is 14 centimeter. Direct. Either they will give you AB or they will give you AC. You have to just multiply it with 2 to get the perimeter of that triangle. So just learn this figure. Now, let's move to question number 9, assertion and reason based questions. Under this, I have written 3 assertion reason for you. Let's read first. The base of an isosceles triangle is bisected at the point of contact of its incircle. The meaning of incircle is that the circle is inside. So I have drawn figure for you, although in exam they will not give you this figure. That's why you should know the meaning of incircle. Now, what is this assertion? They are saying that if it's an isosceles triangle, so let's write that if AC is equal to BC, then they are saying that at the point of contact, that means at D, it will be bisected. AB will be bisected. That means AD is equal to BD. We have to check it's true or false. Just see, suppose that the sides are equal. So let me take that side as X. So AC is also X and BC is also X. We know that they are equal. It's given. Now, you know, using theorem 10.2, because C is an external point here, so length of tangent drawn from an external point are equal. So we can say that CF is equal to C. Let's take that as Y. What you can say about the remaining one, that is AF and AB. What is AF? Total is X, X minus Y. Yes, your AF is X minus Y. And what about your B? Again, X minus Y. From here, again, you can use theorem 10.2 that from an external point, the length of tangents are equal. That means AF is equal to AD. That means your AD is x minus y. Similarly, from an external point B, the length of tangents are equal. So you can say your BD is also x minus y. So what we've seen here that yes, AD is equal to BD. So this assertion is true. Let's see its reason. The length of two tangents drawn from an external point to a circle are equal. Again, it's a statement of theorem 10.2. It's true. Is it a correct explanation? Yes, because we have used this theorem while proving assertion. So that means option is A, that both are true and it's the correct explanation. Let's move to second assertion reason. In second assertion reason, it's given that tangents drawn at the end points of a diameter of a circle are parallel. Let's see what they're saying. That if we have a diameter means that it passes through center, then the tangents drawn from end points of diameter are parallel. Can we say they are parallel? Yes. You, as you know that radius is perpendicular to tangent, you can say here it's 90 degrees. Similarly, radius is perpendicular to tangent, here it's 90 degree, and alternate interior angles are equal. That means yes, the tangents are parallel. It's true. It's an NCRT question that you have to prove tangent drawn at the endpoints of a diameter are parallel. So this is true. Diameter of a circle is the longest chord. Yes, this is also true that diameter is the longest chord. But can I say that it's the correct explanation? No. So answer is not. B option. Now let's move to third assertion reason. In third assertion reason, it's given that from a point Q 13 centimeter away from the center of a circle, the length of tangent is 12, then your radius is 5. We have to check that. Let's draw the figure for this. We have a center. The distance of point Q from O is 13 centimeter and the length of tangent is 12. Length of tangent is 12 centimeter. Now we have to check what about the radius. Now you know that OP is always perpendicular to PQ using theorem 10.1. Now how we can find this OP? Just use Pythagoras theorem. Square root of 13 square minus 12 square. That is square root of 169 minus 144. And that is 25, which is equal to 5. So assertion is true. Now let's move to reason. Tangent at any point of a circle is perpendicular to the radius of the circle. Again, it's true. And is it the correct explanation? Yes, it's a correct explanation because you have used this thing here. That if it's a 90 degree, then only you can use Pythagoras theorem. So it's a correct explanation. A answer is correct. Now let's move to 2 markers. First question in 2 markers. In the given figure, ABC is circumscribing a circle outside a circle. We have a triangle outside a circle. Find the length of BC and it's given that AR is 4, RB is 3 and AC is 11. Let's see this. You know that if we have an external point B, then the length of tangents drawn from an external point are equal. That means these two are equal. We can say that BP is also 3 centimeter. Similarly here, because AR is 4 centimeter and is drawn from an external point A, you can say that AR is equal to AQ. So you can say your AQ is 4 centimeter. If AQ is 4, then what about your QC? That is 11 minus 4. Yes, 7 centimeter because total is 11. If you will subtract AQ, you will get CQ. Now, if this is 7 centimeter again from an external point C, the length of tangent CQ and CP are equal. That means this is also 7 centimeter. So you have to use theorem 10.2 that from an external point, length of tangents are equal 3 times here. Now let's move to next question. Question number 2. A circle is inscribed in a triangle. Circle is inside a triangle. Having sides 8, 10 and 12. So let me write that sides for you. AC as 8. This as 10. And third side as 12. You can take in any order. It will not affect your answer because it's not given in question. You have to find AD. That means this one AD. And your BE, this one, and your CF, this one. Now, how will find that? that tangents drawn from an external point are equal in length. So I'm taking these two as x and x, they are equal. Again, CF is equal to C, let me take that as YY, and BD is equal to BE, let me take that as ZZ. So you will write this in exam that AF is equal to AD, CF is equal to CE, and BD is equal to BE using theorem 10.2. You have to write the statement that length of tangents drawn from an external point are equal. I'm writing directly. Now, just add this. If you will add all the sides AC plus BC plus AB, what you will get? One time we'll write in terms of numbers. So it's 2x, because x plus x, 2y and 2z, and also equal to 8 plus 10 plus 12. From here we can say, if I will take common 2, x plus y plus z is equal to, what is 8 plus 10 plus 12? That is 30. Now just transpose 2 to that side, it becomes 30 by 2, that is 15. So your x plus y plus z is 15. Now we know this thing that x plus y plus z is 15. Now just use these equations that x plus y, what is 8 here? Here 8 is x plus y. So just take this x plus y as 8. Now 8 plus z is 15. That means your z is 15 minus 8, that is 7. Now you know your z. Now let's see another one. We also know that your y plus z is 10. So if I will take y plus z now, y plus z, then I can write that my x plus, what is y plus z? It's 10, is equal to 15. That means your x is 15 minus 10, that is 5. And the remaining one, that is last, y. How I can find y? You can simply write that x plus y plus z total was 15. So we know our x and z. X is 5 and z is 7. So you can find your y from here also. So your y is 3. So if we know the all the three sides, we can find the tangents also. AD, AF, CF, CE, BE or BD using this method. Now let's move to third question. In third question, it's given a triangle ABC is drawn to circumscribe a circle. Circumscribe means outside. So triangle is outside a circle, and it's given that radius of a circle is 3 centimeter and segments BD and DC are 6 and 9. Area of a triangle is 54 centimeters square. So you have to find AB and AC. How will do that? We know that if radius is 3, so here also it's 3 and here also it's 3. Just mark these points as E and F. So this is given that this is also 3 centimeter OE and OF is also 3 centimeter. Now we know one more thing, that radius is always perpendicular to tangent using theorem 10.1. So right here 90 degree, here also 90 degree, and here also 90 degree. Now using theorem 10.2, you can say that from an external point, the length of tangents are equal. You can say BD is equal to BE. That means BE is 6 centimeter. Similarly, you can say that your CD is equal to CF. That means CF is 9 centimeter. And at last, we don't know AE and AF, but we know that they are equal. So we can take that as X. A is X centimeter and this is also X centimeter. Now we'll divide this triangle in three smaller triangles. So we'll join BO, we'll join AO, and we'll join OC. Now you know that if we'll add the area of these three triangles, we'll get the area of full triangle. So let's write this. Area of triangle BOC plus area of triangle AOB plus area of triangle AOC is equal to 54 centimeter square. Now, what is area of triangle BOC? That is half into base into height. Just focus on triangle BOC. So in BOC, your height is this OD, that is 3 centimeter, and your base is BC. So we can say simply half into base into height. Yes, so let's use that here. Base is 6 plus 9, that is 15, into height. Height is 3. Similarly, area of triangle AOB, you can say half into 3 into 6 plus 6. And for AOC, you can say half into 3 into 9 plus 6. Total is 54. Now, if you will see your LHS carefully, we can take 3 by 2 common. We are left with 15 plus 6 plus x plus 9 plus 6 is equal to 54. Now just transpose 3 by 2 to that side, it becomes 2 by 3. So we'll write here 54 into 2 by 3 and just solve the bracket now. 15 plus 6, that is 21 plus 9, 30, and x plus x is 2x. So if you will solve 3 and 54, you will get 18. What is 18 into 2? That is 36. 30 plus 2x is equal to 36. Just transpose 30 to that side. It becomes minus. To 2x is equal to 36 minus 30. That means 2x is 6 centimeter. So from here we can say that our x is 6 by 2, that is 3 centimeter. Now we have to find length of AB and AC. So what are AB? AB is, you can see your figure, that is 6 plus x. So you can write 6 plus 3, 9 centimeter. And your AC is, just see here AC, it's 9 plus x. So you can write 9 plus 3, 12 centimeter. So answer is 9 centimeter and 12 centimeter. Let's move to question number 4. In question number 4, it's given that your angle QPT, let's mark that QPT, this whole angle is 60 degree. Okay, this whole. And we have to find PRQ. PRQ, this we have to find. Take that as X. So we are taking PRQ as X. So no need to write PRQ again and again. We'll write X. Now, can we use any theorem here? Yes, just think. OP is radius and PT is tangent. And we know that radius is perpendicular to tangent. So from here, you can say, if you will take this angle as 1, I can say that my 1 plus 60 is equal to 90 degree, as radius is always perpendicular to tangent. You have to mention that radius is perpendicular to tangent. Theorem 10.1. So from here I can say that my angle 1 is 90 minus 60. That is angle 1 is 30 degree. Now did you observe something? What about OP and EQ? Both are radii and angles opposite to equal sides are equal. So that means this angle too. We can say as OP is equal to OQ. This implies that angle 1 is equal to 2. Angles opposite to equal sides are equal. So from here we can say that our angle 2 is also 30 degree. Now use your ASP to get this angle, that is 3. If you will use ASP in triangle, using ASP in triangle POQ, what you will get? You will get angle 1 plus 2 and both are same. So I am writing 30 plus 30 plus x is equal to 30 plus 30 plus angle 3 is equal to 180. That means angle 3 is 180 minus 60. So 30 plus 30 is 60. And this implies your angle 3 is 120. Now we know our angle 3 also. Is there any relation between angle 3 and angle x directly? No. But what if you will find the reflex of angle 3? This one. What is reflex of angle 3? Reflex of angle 3 means 360 minus angle 3. And that is 360 minus 120. You can say it's 240. Now we have a relation between this, you can say reflex of angle 3 and what we have to find, that is 3. What is that relation? You know that it's a very important theorem in our 9th class. I will just mark that for you with a different color. Just see this angle and this angle. One angle is at center and one angle is at circumference. Yes, it's central angle theorem, very important theorem in 9th class. And that says that your angle at center is double of that in circumference. You can say that this reflex angle is equal to double of x using central angle theorem. Central angle theorem. Or you can write degree measure theorem, whatever you want to write. So this implies that your x is 240 by 2 and that is it's 120. And that's your answer. Angle PRQ is 120 degree. Now let's move to important NCRT questions. So here it's given that we have two concentric circles, one with a radii 5 centimeter and one with radius 3 centimeter. Find the length of common chord of the larger circle which touches the smaller circle. That means what we have to find? We have to find the length of AB. But we know one thing, that perpendicular drawn from center bisects the chord. If you know this theorem, that again that we did in ninth class. So if you know this theorem, that perpendicular drawn from center bisect the chord. I'm writing this for you because in exam you have to mention this. Perpendicular drawn from center bisects the chord. From this theorem, we can say that my AD is equal to BD. And from here, I can say that my AB is double of anything, either AD or BD. I'm taking AD. We have to find AB, and AB is double of AD. That means if you will find your AD and then you will multiply it with 2, you will get your answer. So just focus on this triangle. Just focus on this triangle. And you know that it's 90-degree because radius is perpendicular to tension. In case here it's given, but if it's not given in exam, so you will write that angle 1 is equal to 90, and then you will mention, I'm writing here, angle 1 is equal to 90-degree, radius is perpendicular to tangent, using first theorem. Now whenever we have a right angle triangle and two sides are given to you, how we can find the third side? Yes, using Pythagoras theorem. So using Pythagoras theorem, in triangle ACD, what I can write? I can write hypotenuse square, that is 5 square, is equal to 3 square plus AD square. And that means your AD square is 25 minus 9, that is 16. So this implies your AD is root 16, or we can say 4. We can't say negative 4 because side can't be negative. So you will ignore negative. You will just write 4 centimeter. And from here, we can say that my AB is double of AD. That means it's 2 into 4. Final answer is 8 centimeter. Now let's move to question number 2. This question looks exactly same like 2 marker question number 4, although it's not same because here area of bigger triangle is not given to us. So this is bit lengthy. So let's start this question. Here it's given that your radius is 4 centimeter. So let's join this. That means your OE is also 4 centimeter and your OF is also 4 centimeter. One more thing, that you know that radius is perpendicular to tangent using theorem 10.1. So you can say that OE is perpendicular to AC, OD is perpendicular to BC, and OF is perpendicular to AB using theorem 10.1. Now, you can use this result that length of tangents drawn from an external point are equal. That means CE is equal to CD. You can say that is this is 6 centimeter. Similarly, BD is equal to BF, that is 8 centimeter. But we don't know AE or AF, so you can say that both are X centimeter and X centimeter. Using theorem 10.2, that length of tangent drawn from an external point are equal. Now we'll use one concept here, that area of three smaller triangles, that is AOC plus BOC plus AOB is equal to area of bigger triangle. That means area of triangle ABC. Now, just use this concept again, half into AOC. What is AOC? Base into height. Just see in AOC, your base is 6 plus x and your height is 4. Similarly, in BOC, your base is 8 plus 6, that is 14, and your height is 4. And in AOB, again half into base is 8 plus x into height, that is 4. And we'll find this area of triangle of ABC using herons later on. So right now I'm just solving left side. Okay, now you can cut this half and 4. You're left with 2. Again half and 4. 2 and half and 4. 2. Now you can take 2 outside as common. Now you're left with 6 plus x plus 14 plus 8 plus x. And this is equal to 2 into, what is 6 plus 14? 20. 20 plus 8? 28. 28 plus 2x. Just take 2 common, that is 2 into 2, 4, and you are left with 14 plus x. Okay, now we have to equate this with RHS when we'll solve the area of bigger triangle ABC using herons. That is area of triangle ABC. How we can find this triangle? Because we know that we know the three sides. Your AC is 6 plus x. I can write A. Your BC is 8 plus 6, that is 14 centimeter. And your third side is 8 plus x. First, we'll find semi-perimeter. That is sum of these sides divided by 2. 6 plus 14, 20. 20 plus 8, 28 plus 2x by 2. If you will take 2 common from numerator, what you will get? 14 plus x. And you can cut that 2 with denominator. Now this is your x. Now just use the formula here. We know the formula s into s minus a into s minus b into s minus c. Heron's formula. Just put the values here. S is 14 plus x. 14 plus x minus a. That means minus x because it's a binomial. You will change the sign of both the terms. Then 14 plus x minus 14. And last 14 plus x minus 8 minus x. You have to be very careful that you have to change the sign of both the terms. Most of the students write positive x here. Now, let's solve this. 14 plus x. Can you cut something here? Yes, we can cut an x and minus x. We are left with 14 minus 6, that is 8. Here you can cut 14, 14. You're left with x. And here you can cut x and minus x. 14 minus 8, that is 6. Now let's take the prime factorization. 14 plus x. What is 8? It's 2 into 2 into 2. X you can leave like this only. And 6 is 2 into 3. Can we take something outside the root? Yes. Just see 2 is coming in pair and this 2 is also coming in pair. So you can write 2 into 2 outside, that is 4. And in bracket you are left with 14 plus x into 3x. So we have to equate these two because the area of three smaller triangles is equal to the area of bigger triangle. So equating 1 and 2, what we'll get? Let's see. We can write equating 1 and 2. It's 4 into 14 plus x is equal to 4 into 14 plus x into 3x. We can cut 4 and 4 from both the sides. Now, because here it's under root, x is inside the root, so we have to take square both the sides. You will write taking square both the sides. So this side becomes 14 plus x whole square, and here you are free with the square root, because when you will take the square of square root, you can remove the square root. Now, if we'll divide both the sides by 14 plus x, what you will get? Here you can cut 14 plus x, and here we left with 114 plus x. That means 14 plus x is equal to 3x. Now just transpose x to that side. It becomes 3x minus x, that is 2x. 14 is equal to 2x. That means your x is, just transpose 2 to that side, 14 by 2. You can say your x is 7 centimeter. Okay, now we have to find the value of AB and AC. Now what was my AB and AC? Your AB is 8 plus x. So that you can write as 8 plus 7, which is equal to 15 centimeter. And similarly, your AC is 6 plus x. That you can write as 6 plus 7. And that is 13 centimeter. So this is your final answer, 15 centimeter and 13 centimeter. Let's move to next question. Now in third question it's given that xy and x dash y dash are two parallel tangents. This is given, and what we have to prove? We have to prove that angle AOB is 90 degree. So for that, first thing we have to do is construction. So you will just join OC. Join OC. And just mark these angles as 1, 2, 3 and 4. So now we have to prove that our angle 2 plus 3 is 90 degree because AOB is 2 plus 3. Now, just see this carefully. From an external point, we have two triangles PAO and CAO. You have to always prove these two triangles as congruent. So let's check in triangle PAO and triangle CAO. What you can say? You can say that your OA is common. OA is equal to OA common. You can also say that your OP is equal to OC, radii of same circle. And third, AP is equal to AC using theorem 10.2. I am writing theorem 10.2. In exam, you will write length of tangents drawn from an external point are equal. So these triangles are congruent by triple S. I'm using triple S. Even you can use RHS if you want to write here that these angles are 90p and C using theorem 10.1. But I'm using triple S. So these triangles are congruent. So we can say angle 1 is equal to angle 2 by CPCT. Similarly, you can say similarly these two triangles, this third and fourth triangles are also congruent. So I'm writing similarly triangle BOC is congruent to triangle BOQ. And by CPCT, again by triple S, you can prove that. And by CPCT, you can write that your angle 3 is equal to 4. Now just add these two. Now we know that angle 1 plus 2 plus 3 plus 4 is equal to 180 degree straight angle because PQ is a line. Diameter you can say straight angle. Now, what we need? We need 2 plus 3 is equal to 90. That means we don't need 1 and 4. We don't need 1 and 4. So just replace that 1 and 4. We don't need 1. So we can replace 1 by 2. And what we don't need? We don't need 4. So we can replace 4 by 3. So I can say from here that twice of 2 plus 3. Twice of 2 plus 3 is 180. And that means if you will transpose 2 to that side, it becomes division. So 2 plus 3 is 180 by 2, that is 90 degree. And what is 2 plus 3? This is your angle AOB. Hence proved. Now let's move to question number 4. In question number 4, you have to prove a quadrilateral ABC is drawn to circumscribe a circle. Then you have to prove that sum of opposite sides are equal. If you remember, we used this theorem in one of the question of 1 marker. So this time we have to prove that. Now you know that length of tangents drawn from an external point are equal. So we can say that A is equal to AP. Similarly, BP is equal to BQ. Similarly, CQ is equal to CR. And dr is equal to ds. That we know. Here in LHS we need AB plus CD. Now just think what is AB. AB is AP plus PB. And what is CD? CD is CR plus DR. Yes, and similarly here AD plus BC. What is AD? AD is AS plus SD and BC is BQ plus CQ. So what I will do? I will write left side on left side. That means AP, BP, CR and DR. Now just think that AP is equal to AS, BP is equal to, just see, BQ, CR is equal to CQ and DR is equal to DS. Now you will write using theorem 10.2. I'm writing 10.2. In exam you will write the full statement. Length of tangents drawn from an external point are equal in length. Now we'll mark these as 1, 2, 3, 4 and we'll write adding 1, 2, 3 and 4. Adding 1, 2, 3 and 4. Why we are adding? Because then only we'll get what we have to prove. That means AP plus BP plus CR plus TR. When we add the equation, we add left ones together and right ones together. AS, I'm writing AS and DS together because they will give us AD and BQ plus CQ. Addition is commutative, so you can change the order. Now, what is AP plus BP? That is AB. What is CR plus DR? CD. What is AS plus DS? AD. And what is BQ plus CQ? BC. Hence proved. Now just see next question. In next question, what you have to prove? You have to prove a parallelogram circumscribing a circle is a rhombus. In this question, first you will prove till here. Exactly, you have to repeat that your AP is equal to AS, BP is equal to BQ. So I'm not writing this again. You have to start from here and you have to copy as it is for question number 5. Then you will continue from here. So I'm writing this line, this final line there, and will continue from this line. That is AB plus CD is equal to AD plus BC. So I'm writing from here AB plus CD is equal to AD plus BC. That much we have already proved in previous question, because parallelogram is a type of quadrilateral, so you can just write till here. Now, what is extra given here? That's a parallelogram. In parallelogram, opposite sides are equal, and these two are opposite. And similarly, these two are opposite. So they are equal. So I can write, instead of CD, you can write AB because they are equal. So I'm writing AB plus AB. And similarly, instead of BC, you can write AD because again opposite sides are equal. So we can write twice of AB is equal to twice of AD. Now you can cut 2 and 2 from both the sides. That means AB is equal to AD. Now just see carefully. It's given that its ABCD is a parallelogram. And what is AB and AD? AB and AD are the adjacent side. This is AB and this is AD. A parallelogram whose adjacent sides are equal. A parallelogram whose adjacent sides are equal is rhombus whose adjacent sides are equal is rhombus. That means we have proved that ABCD is a rhombus. So whenever this question will come in exam, first you have to solve the previous question and then you will continue and you will write this. Now let's move to last question of NCRT. Prove that opposite sides of a quadrilateral circumscribing a circle, that means outside a circle, subtend supplementary angles, that means sum should be 180 degree at center. In this question I've given you figure, but in exam figure will not come as it's not in NCRT. So you should know the meaning of question, that we have a circle and outside the circle we have quadrilateral, and we have to prove from opposite sides, if the angle subtended at center, the sum should be 180 degree. So let's start this question. First of all, here I have given you figure, but in exam if figure is not given to you, so you will write construction, that join OS, OP, OQ and OR. Whenever we have an external point, we'll prove these two triangles as congruent. We can easily prove that by triple S. So let's prove that first. We'll write in triangle ROC, any two triangles you can select. I'm selecting these two, ROC and QOC. Your OC is common. Your OR and OQ is radii of the same circle. And third, your CR is equal to CQ as length of tangents drawn from an external point are equal. I'm not writing the statement, but you have to write the statement. So by triple S, you can say that they are congruent. You have to be careful that you have to always select triangles from the external point. That means these two. Don't select QOC and QOB. Okay, so from here we can say I've already marked the angles for you. That is, this is 6 and this is 5. So I can say angle 6 is equal to 5 by CPCT. Now we'll not prove for other triangles. We'll write similarly. Similarly, we can say that these two triangles, third and fourth, are similar. That means angle 3 is equal to 4. This triangles, fifth and sixth, again, they are similar. So you can say angle 1 is equal to 2. And then 7 and 8 are also similar. So you can say that angle 7 and 8 are equal. All are by CPCT. Okay. Now, what we know about this, because we need number 180. Did we know something about number? Yes, we know that sum of all angles 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 is, yes, it's a complete angle. Let's make a full circle, 360. It's a complete angle. Now just think what we have to prove, which numbers we need. if we have to prove sum of opposite angle is 180, so I'm taking these two opposite right now, this one and this one. You can take any two opposite, so I'm taking these two. So that means I have to prove 7 plus 6 plus 2 plus 3 is equal to 180. So what I don't need 1, 4, 5 and 8. So I will eliminate that. I don't need 1. Instead of 1, what I can write? You will not cut in exam. I'm just cutting this to explain you. 1 instead of 1 I'm writing 2. 2 we need. We need 3 also. We don't need 4. Now angle 4 is equal to just here 3. So replace 4 by 3. We need 5. No, we don't need 5. So we'll replace 5 by 6. We need 6. Yes. We need 7. Yes. So we don't need 8. We just replace 8 by 7. Now we have twice of 2 plus 3 plus 6 plus 7. That is 360. Now you will transpose 2 to that side. You will get 2 plus 3 plus 6 plus 7 is 180, because 360 by 2 is 180. So hence proved. Similarly, other side, 1 plus 8 plus 4 plus 5 is 180. Now let's move to extra practice questions. Just see this question here. What is given to us? It's given that AB is 29 centimeter. I will write directly. AB is 29 centimeter. This full. And your AD is 23 centimeter. This is 23 centimeter. DS is 5 centimeter. And we have to find radius. Did you observe something, that this is a R, this is R, so these two are equal radius, and here these two sides are equal. Why? BP is equal to BQ, because using again theorem 10.2. So this is square because all angles are 90 also. Okay, let's start this now. Again we'll use this theorem 10.2, that length of tangents drawn from an external point are equal. So let's continue. Here it's 5, so we'll write this is also 5. These two are equal. You will write like this: ds is equal to dr, which is equal to 5 centimeter. Theorem 10.2, length of tangents drawn from external point are equal. Now we know that dr, so can I find ar? What is ar? Ar is 23 minus dr, and that is 23 minus 5. You can say ar is 18 centimeter. So you can write your ar is 18. Now if you know that ar is 18, you know that ra is equal to aq, again using theorem 10.2. That means your AQ is 18 centimeter. Now, if AQ is 18, what you can say about BQ? BQ is 29 minus 18. That is 11 centimeter. And when this is 11, this is 11. As I told you, it's a square. So your radius is also 11 centimeter. Now, let's move to last question. In last question, it's given a tangent of length L. Let's draw the circle first. And we have a center O, and then they are saying a length of tangent L is drawn. So this is the length of tangent. It's given L, which is equal to 4 by third of R, and radius is R. You have to find the distance of this point P, smallest distance of this point P to the circle. That means you have to find this much. I can write this Q. Let's write this. You have to find PQ. How you will find that? Just use this thing, theorem 10.1 again, that angle 1 is equal to 90 degree. Radius is perpendicular to tangent. Now using Pythagoras theorem, in this triangle you can write that your r square plus 4 by 3 of r square is equal to OP square. That means r square plus 16 by 9 r square is equal to OP square. If you will take the LCM, you will get 9 r square plus 16 r square, that is 25 r square by 9 is equal to OP square. Just take the square root to get OP, and that will give you 5 by 3 r. This is our OP, 5 by 3 r. But we need QP. And what is a QP? Or you can say PQ. That is OP minus OQ. OP is 5 by 3 of r. And what is OQ? That's radius. So just subtract that. Again take the LCM. You can write that is 5r minus 3r, or you can say 2 by 3 of r. Now it's time for your concept checker. If you really understood today's topic, you should be able to solve this question without any help. These topics are carefully selected to help you understood concepts clearly and score better in exam. If you found this video helpful, don't forget to like, share and subscribe to my channel Mathify with Meenakshi. Keep learning, keep practicing. Thank you everyone.